Hello and welcome to episode 160 of our SAP on Azure video podcast. Today is September 14th, and together with Robert and Goran, we are here to talk about anything related to SAP and Microsoft. Hello, everyone. So today we are going to talk about manufacturing ontologies. I have to admit that I needed to look up what this exactly means. And on the related GitHub page, it says an ontology defines the language used to describe a system. In the manufacturing domain, these systems can represent a factory or plant, but also enterprise applications or supply chains. So the Digital Twin Consortium has created an open source manufacturing ontology reference architecture, where until recently, one of the most requested features was the integration of the on-premise SAP systems. I say until recently, because our guest today, Erich Barnstedt, just recently published exactly that. And since this week we don't have a lot of updates, I guess this will change after the DSAC conference next week. Let's switch over to Erich right away and talk about the SAP integration in manufacturing ontologies. Erich, first of all, welcome and thank you very much for joining our podcast. Can you maybe quickly introduce yourself? What do you do at Microsoft?
Yeah, thank you, Holger, and thanks for having me on the show. So I'm Erich Barnstedt. I'm the Chief Architect for Standards Consortia and Industrial IoT in the Azure Edge Platform team. Been with Microsoft for over 20 years and, started the Windows Industrial IoT team. Later started the Azure Industrial IoT team and built both teams. Worked on products in relation to industrial ontologies and manufacturing ontologies. And recently was approached by our Azure Digital Twin team that said we have a reference ontology for the building automation space based on real estate core. And again, you gave a great introduction to what an ontology is. It's nothing more than a language to describe a system, right? So the terms to describe the systems are defined, and so that everybody has the same terms and the same language describing a system, creating interoperability. And we looked at manufacturing space and we said, okay, well, if we were to build an ontology for manufacturing, what would that be? And very quickly we realized ISO 95 is the most common ontology used and to describe manufacturing processes and manufacturing systems and manufacturing plants and production lines and all these kind of things. So we said, okay, we'll base our ontology on ISO 95. So that's a standard. It's an IC standard, very common. And if you look at factories today, some people call it the automation pyramid, but they have segregated the different systems into different layers, and each layer has its own network and so on. And ISO 95 basically defines that too, right? So we had good reasons to use ISO 95. So we started basically mapping the ISO 95 standard to the Microsoft internal representation for digital twins. Again, this was started with the digital twin team. And so we created this mapping from ISO 95 to the digital twin definition language, which is, of course, is an open specification that Microsoft released specifically for digital twins, right? So we started with that, and that was great, but very quickly, and then we contributed to the Digital Twin Consortium because we wanted it to be open, we wanted it to be out in the community, and hopefully also get contributions from the community to it. And obviously people were interested, they liked the idea. But very quickly they said, well, how do you use it? I mean, can you give an example, or can you show what an architecture would look like where we would use this? And very quickly we realized we need to do more than just define the ontology. We need to actually create an architecture and integrate other Azure services into it. And then we said, okay, how do we do that, right? So we ended up creating a V team within Microsoft. Very quickly, the folks from the Microsoft Cloud for Manufacturing joined. A lot of the MTCs, or Microsoft Technology Centers, they have their own engineers in there. They were really interested because it's a great demo, right? And so we created this V team, which was far beyond just the digital twin team. It was basically all the manufacturing stakeholders at Microsoft. I volunteered to lead that V team. We meet weekly, and we basically started creating more assets around this concept of manufacturing ontologies. So we created an asset which does automatic translation from OPC-UA, which is a industrial interoperability standard used in a lot of machines and systems to find on-prem, but they also define a way to send data to the cloud, which we helped define. It's called OPC-UA PubSub. So we created assets that would take the metadata from OPC-UA PubSub and create those digital twins automatically, which was another big ask that people had because they didn't want to have to model things that they'd already modeled before, even if it was done, even if the modeling was done in OPC-UA, right? So that was one big piece. And then, of course, we integrated our new edge based on Kubernetes, Azure Kubernetes Service Edge Essentials. That was a big piece. And then we said, okay, where do we get the data from? I mean, it's all well and good to have an architecture, but if you want to showcase it, if everything is always zero, that's kind of lame, right? So we took the very, detailed and complete simulation that we had in an Azure Connected Factory and brought that in so we could simulate production lines. We added shift times to that simulation. So, you're not always producing day and night, but you're producing in shifts. We brought a bunch of analytics software into it that is available in Azure. And in the end, we created this massive, reference architecture centered around Azure Digital Twin Service with the ontologies from ISO 95 and Azure Data Explorer for time series data that we could then analyze, right? And we then contributed, every time we made a change, we contributed that back to the Digital Twin Consortium. And then finally created like a deploy to Azure button and a deployment script where you could deploy the whole solution with one click, because setting it up individually and manually was getting more and more complicated and took longer as we kept adding new things to it. And then, of course, somebody said, hey, what about MES and ERP systems, right? And I went, well, yeah, yeah, so that's missing. And they said, well, what about integrating on-premises SAP systems, right? Because we heard from customers all the time that this was, something they wanted done. This was something that, we had talked about in different blog posts for a long time. So we said, okay, let's do it. Let's integrate SAP, right? And of course, we reached out to our SAP friends in Waldorf, which were really helpful. And we created what every expert, and I'm not an SAP expert, but every SAP expert I talked to agreed that that was the perfect architecture. So effectively, what we've done is we've connected the SAP systems through HTTP to Azure Logic apps in the cloud. So this is an outbound connection, right? And then Azure Logic apps would basically parse the data coming from SAP in IDOC format, and then create digital twins automatically or store the IDOC in Azure Data Lake, for further processing there. And that's basically what we did. And then, of course, people say, yeah, well, that's all well and good, but what about the return path? How do you send data from Azure back to on-premises SAP systems? And there, actually, we have quite a lot of infrastructure already, and there's a team building that. I think originally it was built for Power Apps, but it also works with Azure Logic Apps. It's called the Data Gateway, and it translates requests back to the SAP protocol RFC, I believe. Yes, and that's also something we integrated for completeness, right? So we
have now sent this bi-directional now.
Bi-directional, we can send data from on-premises SAP systems to Azure and back, okay? And then, of course, it came to actually documenting all the configuration steps in SAP and all the configuration steps on Azure. And that was something that we did over the last few weeks. We've more recently also added screenshots because people said, yeah, I mean, I'm going blind just reading this text. Like, seeing is believing, can you add some screenshots? So we added some screenshots. And people are generally super excited about this. When we talked about that we made this contribution to the D2C on LinkedIn, we got a lot of response, positive response. People were, really happy that we finally had this documented and integrated with the ontologies work that a lot of folks had already started adopting, right? So that's what we did. Again, it's on GitHub, it's open source. Anybody can use it. The Digital Twin Consortium is very good at expanding their open source initiative with things like this. And they're very helpful when it comes to answering questions as well. If you haven't used GitHub before, or if you're new to open source, reach out to them. And quite frankly, we are also very keen on contributions from the community. So far, I mean, we have roughly 10 people that have contributed to this particular GitHub repo, mainly from Microsoft, as you can imagine. But there are other people that said they wanted to contribute, but haven't so far. But clearly there's a need there for making it better, for continuing to evolve it as new use cases are identified. So that's what we're looking forward to. So it is a community project. That's what it's there for. It does have some other open source components in it. As new Azure services that are relevant in the manufacturing space become available, of course, we're going to integrate those too. We're going to keep it relevant. We're going to keep it fresh. And a lot of folks use this simply because it brings it all together, right? For the first time, we always had kind of little solutions here and there for manufacturing, and it was up to our partners or our customers to figure out how to connect them all. Now, for the first time, we're creating one solution that has everything integrated, right? And we have a long list of additional stuff we want to integrate, so we're not going to stop. We have lots of requests, and we keep innovating, right? Because if you create those solutions once, lots of people can benefit and save time and money.
I mean, when I first looked at the ontology architectures there, I was actually super impressed by how comprehensive this is. I mean, typically, and I think you made a very good point. Typically, when we look at individual solutions, when we look at logic apps integrating with SAP or something like that, there's a nice tutorial that helps you how to do this point to point or something like that. But that's it. It's not in this broader context. And when I looked at the GitHub page that you referenced, there's a reference architecture built, a picture in there. And it's amazing, like how many components are there and how they interact, and you really see this completeness of the solution. So that it's really not, well, this is how you do it, and if you really want to implement this in your company, then you're on your own. But no, it's really an amazing foundation that talks about all these different services in the context of the manufacturing industry. So it's really an amazing asset, I guess. And we talked before. I mean, obviously, this is not only something that you do in theory and completely decoupled from customers, but you are working with the customers. You are getting the feedback from the customers that then maybe the customer is not an active direct contributor, but via some other colleagues, all these the feedback is actually channeled back into the GitHub even today.
Correct. And I mean, of course, I'm also working with the product teams, right? So the feedback doesn't stop with me. I'm passing the feedback on to the product teams, who then can adopt their product plans and at least add the request to the backlog for a future version of the product, right? So it's a two-way road, right? So we're showing our customers this is what a complete reference architecture looks like, and how how it works best. I mean, we also optimize the performance and cost, right? So we went through several iterations actually of the architecture, and always looking for ways to save our customers cost and to also improve performance. So we had several demos based on this architecture at Hanover Messe this year, and some customers looked at it as well, following that, and said, well, this could be faster, this is not so important, but focus on this. you know, and so on. And we did, right? And we optimized the architecture for cost and performance. So you'd be surprised how little it actually costs to run this thing, right? But anyway, this is what we aim to do. We want to, you know, build architectures that are, you know, relevant, that are production ready, and this is a good step in the right direction, right? And I mean, to be honest, one thing that SAP and Microsoft have also been working on for quite some years now is the asset administration shell, right? So this is also the first time that we've integrated the asset administration shell into an overall architecture. And I know SAP has a dedicated team for working on asset admin shell. We have, you know, obviously not a dedicated team, but we have several teams that are interested in adopting asset admin shell technology. We contributed a reference implementation also to the DTC, so Digital Twin Consortium, for the asset admin shell running on Azure and integrating with other Azure services. So this is also part of the solution, and in the reference architecture, it's used for product carbon footprint calculation.
Oh, okay.
Which is a hot topic, obviously. Yep. But it is also a very good way to interact with other SAP systems, like, for example, Asset Intelligence Network, right? So this is something we've been working with inside another consortium with SAP. I'm in weekly open source calls regarding asset admin shell with a lot of the other SAP contacts that we have. And then finally, the other standard, which we obviously integrated, already mentioned it a little bit, is OPC-UA. Obviously, both SAP and Microsoft are on the board of the OPC Foundation, and we're collaborating with SAP on OPC-UA integration as well. Their product is called Plant Connectivity. Our product is called OPC Publisher. Okay. And, you know, obviously, you know, we're collaborating in several different places with SAP, but I would say the main ones relevant is this ontology here, the asset admin shell standardization and reference implementation or open source work we're doing with SAP, and then finally OPC-UA as the third major area, let's say, right? And so again, this architecture brings it all together because we have integrated the asset admin shell, we have integrated OPC-UA, we've integrated on-prem SAP systems. So really, I mean, we have lots of touch points, obviously, with SAP, as you know, Holger, right? So this is trying to bring this all together as well. So people who buy software both from SAP and Microsoft know how to combine them, right? Yeah.
Can you show us the architecture maybe? Can we take a look at the GitHub repo, and then I mean, it's as you said in the beginning, it's massive in the meantime, but maybe you can just show us a few of the topics.
I keep saying I'm running out of space. Well, there's still a few empty spots that I could add more services, but this is it, right? So it looks overwhelming at first, but if you dig into it, I mean, you can see you have your on-premise systems on the left, then you have your edge gateway that sits usually in the IT network, but can also sit on the OT network, and can be daisy chained over several networks. And then you have a broker in the cloud. So this is on-premises, this is cloud. You have a broker where the data comes in. And then the metadata is sent through the component I mentioned. It's called UA Cloud Twin, which automatically generates digital twins from the OPC-UA metadata. And then you're also sending the OPC-UA metadata and telemetry data to Azure Data Explorer. So those are the two main components of the architecture. That's where the data is stored. And then everything else just runs queries off of those components, right? The asset administration shell that I mentioned earlier to calculate the product carbon footprint also queries that data. And for example, you know, I don't want to go into the details. I just gave a webinar on this particular asset admin shell in the Digital Twin Consortium yesterday, so you can watch that. But basically, product carbon footprint has several different components. So you need to grab the data from different places, right, to calculate the product carbon footprint. And this is what this does. It's built into the asset admin shell. And there's several different databases that it needs to query for the data. One other thing that might be worth mentioning is digital feedback loops. So as you're analyzing your data here, you can obviously create actions that you want to perform on your production line. So this UA Cloud Action open source component that we also contributed to the Digital Twin Consortium can handle that, and then goes back through the broker and back into a component called UA Cloud Commander, which then impacts your production line. But from the discussion we had, obviously the SAP systems are up here. Here's the trigger, the HTTP request that I mentioned that goes through Azure Logic Apps, which then has an impact on digital twins being created in Azure Digital Twin Service. There's also a link between here and the storage account, but if I create an arrow straight through the architecture, it becomes really, really unwieldy. So I decided to leave that arrow out, but it's the steps to set up the connection between Azure Logic Apps and the Azure Storage account are mentioned below. And then the feedback loop, or the return path, let's say, go through an RFC workflow trigger through the data gateway, which is also running on the edge, which then connects to the SAP systems through the so-called SAP connector, which is again RFC. So that's how the whole system works. Maybe also quite interesting to some of the viewers is we integrated Azure OpenAI service. We can do automatic asset onboarding using a component called UA Edge Translator. So if an asset doesn't have OPC UA built in, you can automatically translate it to OPC UA without having to manually map tags all the time, which is a very time-consuming task in an industrial IoT project. So that's what we use Azure OpenAI service for. And then on the right, you have the different applications to visualize the data, to do more calculations. For example, Microsoft Sustainability Manager also has the ability to calculate the product carbon footprint. Azure Data Explorer obviously is a no-code dashboard for Azure Data Explorer. Azure Data Explorer dashboard, sorry, that's the official name. It's just dataexplorer.azure.com. You can log into it, create dashboards with a few clicks, and connect to your database. And yeah, we have Power BI integration, Grafana integration. We even have a industrial metaverse application we built using Unity that also the Digital Twin Consortium and the OPC Foundation collaborated on. And then, of course, we have our 3D Scene Studio and Digital Twins Explorer for visualizing your digital twins, right? Which is also something a lot of folks are interested in. And again, it comes with lots of documentation. Let me just make that a bit smaller again so you can see it properly. So more recently, we added a table of contents because there's so much content.
It's huge
now,
in the meantime.
Right, so the SAP integration is discussed here. This is how you set up the Logic app. Down here, you have the screenshots I mentioned regarding the SAP configuration that you need to do, which is basically setting up an endpoint, right, in SAP, and then how to test your solution, right, to make sure it's all working. And a quick explanation about the data gateway, what that is for. And then the other thing I wanted to show is this is the Grafana integration, the dashboard for Azure Data Explorer. Azure Data Explorer, one of the most underrated features of Azure Data Explorer is actually its functionality to do calculations on the data, right? So you can do a whole OEE calculation right in Azure Data Explorer, right? Without having to write any code, which is exactly what we did here. And of course, we also make the dashboard for this available as part of the solution. So you don't even need to create the dashboard. It's done for you, including the OEE calculation. And then here's the button to deploy everything to Azure.
And
footprint calculation. Yeah,
so this button to deploy to Azure, what is actually deployed to Azure then? I mean, is really the whole reference architecture deployed, and I basically just need to go in and do some final custom configurations and obviously, I mean, connectivity to the SAP system and stuff like that, but the services
so it leverages the Azure Resource Manager. And it's an Azure Resource Manager deployment script. So the entire solution is deployed, including the simulation.
Nice.
The simulation runs in the VM on Azure, right? For the production line simulation, right? So that's all part of the solution. And all you literally have to do after clicking that button is to start the simulation. One command.
Oh, cool. Yeah.
So that's it. Actually, no, I lied. It's 2 steps. So you need to also deploy the Kubernetes instance. That's one command, and then it's another command to start the simulation. But that's it. That's it.
Nice.
So then the data starts flowing, and you can do all your calculations. Here's the shift times that we use in the simulation identified. I'm just looking for the picture for the 3D Studio. Oh, here it is. Look, so there is also a 3D wireframe sample of a 3D robot or an industrial robot that we provide, where you can attach your digital twin to, right? So in Microsoft Azure Digital Twin service, the digital twin is basically a representation of your physical asset, and it has telemetry, it has methods, it has Azure functions that you connect to it. So based on some threshold value, you can execute some code or whatever, to basically react to something that the robot did. But you can also attach a 3D wireframe with textures, as far as I know, to it, right? So you can really create a representation, a 3D representation of your production line on Azure, right? And that's something a lot of folks are excited about. So it can be done with this solution as well. And then the industrial metaverse is then taking that to the next level, where I have one of those VR headsets, and a Unity obviously supports our Microsoft Mixed Reality Toolkit, right, which supports a bunch of different VR headsets and HoloLens. So the application that we integrated, that we contributed to the solution, supports both, right, because the Mixed Reality Toolkit abstracts the actual hardware that you use. So we took this reference architecture to simulate a wind park, and it was a demo at Hanover Messe. So we placed the wind park on Azure Maps where the Hanover Messe fairgrounds are.
And then you could really walk.
We converted it into a wind park, right? And you could wear the VR headset and see the Hanover Messe fairgrounds and the wind turbines on top. And of course, telemetry data was OPC-UA, and we're using digital twins from the ontology and so on. So it really was a nice demo to create something that hasn't been done before, right? Oh, cool. So that's pretty much it. So have a look at it. It's GitHub Digital Twin Consortium Manufacturing Ontologies, right?
I'll put the link in the show notes.
Link to it in the description of the video. And it's a reference. Use it to get going using Azure services for manufacturing, and give us feedback. And even better, make a contribution to it.
Contribute, exactly, yeah. And
so
I mean, we just saw it. It's very easy to get started, even with simulated data. So you should be able to really test this out. And then, I mean, we talked about the Cloud Appliance Library, the SAP Cloud Appliance Library in previous episodes. So it's very easy for you to set up an SAP system, and then you can run through the connectivity that you described. I mean, there were some nice screenshots on what is required in the SAP GUI for the configurations to set up these endpoints. Yeah, so hopefully a few of our viewers will actually really get started, will click on the deploy to Azure button and make the connection hopefully to SAP, and then provide feedback.
Correct. Yeah, and we're always interested in feedback. We always want to improve what we have. And should you have any problems, just open an issue on GitHub, and we'll get to it. We have very good turnaround time. So our so far we've been less than 24 hours to turn around issues. So hopefully we can keep that. right? And make sure that we enable you as quickly as we can, right?
Perfect. Well, Erich, thank you so much for this insights. I think it's really absolutely amazing how much content is already there. And I mean, if you look at the GitHub page, it's really, there's a lot of documentation and beautifully documented, as we just saw with all these screenshots. Thank you so much for sharing this. And yeah, maybe we'll get an update from you in the future on some other cool stuff that will come.
Yeah, like I mentioned, we have a long list of additional things we want to do. We'll get to them bit by bit, right? Integrate new Azure services, add new features, enable new use cases. The list is long, right? But we'll get to it, and we'll keep improving on it. And Thank you for having me on the show.
No,
Appreciate
thanks.
it.
Thanks for coming. Yeah, cool. Then talk to you, in the future again.
Absolutely. Talk to you soon.
Thank you.
Cheers.
Bye-bye.